Welcome to SwiftUI Codes. In this tutorial series, you'll learn to build a professional Pomodoro Timer app from scratch. We'll cover focus mode for deep work sessions, break timers for rest periods, beautiful animations and transitions, and modern SwiftUI architecture. Get ready to master SwiftUI and build something amazing. Let's begin. Welcome to the Pomodoro Timer tutorial. In this lesson, we'll define timer modes using Swift enums. We'll set up duration, colors, and icons for each mode. By the end, you'll have the foundation for a professional timer app like the one you see on screen. Here's what you'll learn in this lesson. First, the focus mode for 25-minute work sessions. Second, short break mode for 5-minute rests. Third, long break mode for 15-minute breaks. Fourth, animated circular progress rings. And finally, floating particle effects for that premium feel. First, we import the SwiftUI framework. This single line gives us access to all SwiftUI components: view, text, color, animation, and more. SwiftUI is Apple's modern declarative UI framework that makes building beautiful interfaces simple and intuitive. Now we create an enum called TimerMode. Enums in Swift are used to group related values together. This enum will represent the 3 different states our timer can be in: focus mode for working, short break for quick rests, and long break for extended relaxation. We add 3 cases to our enum. The focus case is for deep work sessions. Short break is for quick 5-minute rests. Long break is for longer 15-minute relaxation periods. We use string raw values to give each case a human-readable name. The case iterable protocol lets us loop through all cases later. Now we add a computed property called duration. This property will return the time for each mode in seconds. We use switch self to check which mode we're in and return different values accordingly. Computed properties are calculated each time they're accessed. We set the duration for each case. Focus mode is 25 minutes, so we multiply 25 by 60 to get 1500 seconds. Short break is 5 minutes, giving us 300 seconds. Long break is 15 minutes, which equals 900 seconds. Look at the preview. You can see the timer showing 25 minutes for focus mode. Next, we'll define a unique color for each mode. This computed property returns a SwiftUI color. Different colors provide visual feedback when the mode changes, helping users instantly recognize which mode they're in without reading text. For focus mode, we choose orange. It represents energy and concentration. Short break gets mint color. It feels fresh and refreshing. Long break uses indigo, calm and restful for extended relaxation. Look at the preview showing the 3 mode selectors with their distinct colors. Now we add gradient colors for the progress ring. Instead of a single color, we use 2 colors that blend together for a more professional, premium look. Focus transitions from orange to red. Short break goes from mint to teal. Long break flows from indigo to purple. Watch the circular progress in the preview. Finally, we assign an SF symbol icon to each mode. Focus gets the brain icon, symbolizing thinking and concentration. Short break gets the coffee cup, perfect for a quick rest. Long break has the moon and stars, representing peaceful rest time. This completes our timer mode enum. Here's the complete timer mode enum. Copy this entire code block into your Swift file. This enum defines all timer modes with their durations, colors, gradients, and icons. In the next lesson, we'll build the Pomodoro Timer view model that uses this enum. Now let's build the brain of our timer, the Pomodoro Timer class. This view model will manage all timer logic. Using the observable object pattern, SwiftUI views will automatically update whenever our timer state changes. This is the MVVM architecture in action. Here's what you'll learn in this lesson. First, the observable object protocol for reactive programming. Second, the published property wrapper for automatic UI updates. Third, timer scheduling with Foundation's timer class. And fourth, State Management Best Practices. We create a class called Pomodoro Timer that conforms to Observable Object. This is a protocol from the Combine framework. When any published property inside this class changes, SwiftUI views that observe it will automatically re-render. This is the foundation of reactive UI in SwiftUI. We add our first published property, time remaining. The @sign published wrapper tells SwiftUI to watch this variable. Whenever its value changes, any view observing this object will be notified and update automatically. It's an int that holds the remaining time in seconds. We add 3 more published properties. Is running tracks whether the timer is actively counting down. It starts as false. Current mode holds which mode we're in, defaulting to focus. Completed Pomodoros counts how many focus sessions we've finished. Look at the preview showing 2 completed sessions. We add a private timer variable from the Foundation framework. This is the actual system timer that will fire every second. It's marked private because views shouldn't access it directly. They only need to see the published properties. This is proper encapsulation. The init function runs when the class is created. Here we set time remaining to the focus mode's duration. That's 25 minutes or 1500 seconds. This means when the app launches, the timer is ready to start a focus session. Look at the preview showing 25 minutes. The progress computed property returns a value between 0 and 1. We convert both total duration and remaining time to double, then divide them. When the timer is full, progress is 1.0. As time passes, it decreases toward 0. This value drives our circular progress ring animation. The time string property formats seconds into readable time. We divide by 60 to get minutes, use modulo to get remaining seconds. The format string with %02d ensures 2 digits with leading zeros. So 303 seconds becomes 05:03. See the timer showing 05.03 in the preview. Here's the complete Pomodoro Timer view model so far. Copy this code below your TimerMode Enum. It includes all published properties, the initializer, progress, and time string. In the next lesson, we'll add the start, pause, reset, and switch mode methods. Now let's make our timer work. We'll add start, pause, reset, and mode switching methods. We'll implement start, pause, reset, and mode switching functionality. Start creates a timer that fires every second. We use weak self to prevent memory leaks. At 0, timer completed is called. Pause sets is running to false and invalidates the timer. Simple but essential for user control. Reset pauses the timer and restores the full duration. Users can start fresh anytime. Switch mode pauses, updates the mode, and sets the new duration. Manual switching between modes. Timer completed handles the workflow. After focus, increment, counter. Every 4th Pomodoro gets a long break. Classic Pomodoro technique. Here's all the control methods together. Add start, pause, reset, switch mode, and timer completed to your Pomodoro Timer class. These methods complete the timer logic. The app now follows the Pomodoro technique. Focus, short break, focus, long break. Now for the visual star, the circular progress ring with animated gradient. We'll learn circle, stroke, trim, and angular gradient for a premium look. Circular progress view takes progress, mode, and time string. Z-stack layers circles. Frame is 300 hard 300. First layer, background circle. Stroke creates a ring at 20% opacity. Line width is 20 points. Progress circle uses trim to show partial circle. Angular gradient sweeps colors. Rotation effect starts at top. Inner glow with radial gradient fading to clear adds depth and polish to the design. Center content, mode icon, time display with thin weight, and mode label. Monospaced digit prevents jumping. Here's the complete circular progress view. This beautiful component shows the progress ring with gradient colors, inner glow effect, and centered time display. Copy this struct to your Swift file and use it in ContentView. Now let's create interactive buttons, mode selectors and control buttons with beautiful animations. We'll build custom button styles with scale animations and touch feedback. Mode selector button shows icon and name. Selected is white, unselected is faded. V-stack stacks icon above text. Background changes on selection. Selected gets color tint and border. Scale effect enlarges selected. Spring animation for bounce. Control button creates circular buttons. Gradient background adds depth. Shadow creates floating effect. Scale button style scales to 92% when pressed. Spring animation makes it feel natural and responsive. Pomodoro counter shows 4 dots. Dots fill as Pomodoros complete. Ultra-thin material for frosted glass. Here are all the button components together. Mode selector button for mode tabs, control button for play, chant pause, chancha reset, scale button style for press feedback, and Pomodoro counter for tracking sessions. Copy all these to your Swift file. Let's add floating particles. Subtle animations create an ambient, calming atmosphere. We'll learn random generation, geometry reader, and infinite animations. Particle struct stores properties, position ratios, size, opacity, duration, delay. UUID makes it identifiable. Geometry reader gets screen size. Particles positioned using ratios works on any screen size. Offset animates between 20 and +20. Ease and out, repeat forever with auto reverse. Unique delays for organic feel. On appear, create 15 particles with random positions, sizes, timing. Color animates on mode change. Here's the complete particle system. The particle struct stores properties, and floating particles creates the ambient animation. These subtle floating circles add a premium, calming atmosphere to your app. Copy both structs to your Swift file. Time to assemble ContentView. We'll layer background, particles, and UI. State object owns the timer. We'll add gradient background, particle layer, timer display, and control buttons. State object owns Pomodoro Timer, persists across view updates, ZStack layers background, particles content. 3-color gradient background. Ignores safe area extends to edges. Particles colored by current mode. Header. Title on left, session count on right. Hstack with spacer pushes to opposite edges. Timer centered with spacers. Circular progress view and Pomodoro counter use state object data. For each loops through TimerMode cases, button checks if selected. Tapping calls switch mode with spring animation. Here's ContentView with everything layered together. Background gradient, floating particles, header, timer, counter, and mode selectors. In the next lesson, we'll add the control buttons to complete the app. Final piece, control buttons. Reset, play, pause, and skip with dynamic icons and animations. We'll add reset, play.pause toggle, skip button, and dynamic styling. Reset uses counterclockwise arrow, gray for secondary action, size 56, spring animation. Play pause is the star. Icon switches based on is running. Mode color, size 80, toggles start and pause. Skip advances to next mode. Find index, add one with modulo to wrap, then switch mode. Three buttons in Hstack. Play is larger, colored. Gray secondary buttons. Bottom padding for home indicator. Here's the complete control buttons section. Reset, play, pause, and skip buttons with animations. Add this Hstack after the mode selectors in your content view. Your Pomodoro timer is now fully functional. Almost complete. Preview macro, architecture review, and enhancement ideas. Production quality app. Preview, code review, enhancement ideas, and course summary. Preview macro enables live preview. 3 lines for real-time updates, powerful for rapid development. Architecture review. TimerMode Enum, Pomodoro Timer class with observable object, 5 custom views, clean separation. Enhancement ideas, notifications, stats tracking, sounds, customizable durations, widgets, iCloud sync. Congratulations! Complete Pomodoro Timer with enums, observable object, custom views, animations. You're a SwiftUI developer. Here's part 1 of the complete app. This includes the TimerMode enum with all properties and the Pomodoro Timer ViewModel with state management and timer logic. Continue to the next step for the UI components. Part 2 contains all the UI components. Circular progress view for the timer ring, scale button style for press animations, mode selector button for mode tabs, control button for play, for pause, bar, reset, and Pomodoro counter for session dots. Next is the particle effect and main view. Part 3 adds the floating particle effect. The particle struct stores properties for each particle, and floating particles creates the ambient animation with random positions and timing. This gives the app a premium, calming atmosphere. Part 4 is the final content view that assembles everything. It layers the gradient background, floating particles, and all UI components. The state object owns the timer, and all controls are wired up with spring animations. Your Pomodoro timer is complete. Thank you for learning. Keep building. Stay productive. Go change the world, one Pomodoro at a time.